So at AMP, we build entire waste recycling and processing facilities where in those facilities you see this maze of conveyor belts. And let's start by talking about conventional recycling facilities. When you put your recyclables in your bin out on the curb, a truck goes and collects that mixed material, and it'll get brought to a recycling facility in your municipality if you have a recycling program. It gets dumped in a gigantic pile on a tip floor, and a front loader will come take a bucket of that and put it in the system. And by system here, I mean a maze of conveyor belts. It'll get dropped on the first conveyor belt. And typically, the first thing that's done is called a pre-sort. Take out all the really big stuff that people wish cycled that will break the machine if it goes through. And wish cycling a red Solo Cup is really no huge sin. People put anything you can imagine in the recycling bin. You'll see entire pieces of furniture, bicycles, bowling balls. We've really seen it all. And every time we see the next funny thing, we make sure to take a picture of it. People will really wish cycle whatever you could imagine. But you want to take out the stuff that is too big or will otherwise damage this maze of conveyor belts. In traditional facilities, that maze of conveyor belts is going to then take the stream of intermixed material and use a series of purpose-built pieces of heavy machinery to separate those streams into maybe high-density things, low-density things. A magnet to pull off the metal. An induced eddy current to pull off the conductive aluminum. A screen to let the small stuff fall through and the medium and large stuff go over the top. And so in traditional recycling facilities, you have this maze kind of conveying the material to each sort point where something will sort the material, usually using some basic principle of physics. And you'll end up with these conveyors that have a more limited set of your recyclables on it. You almost always have a fiber line, which has cardboard, paper, and then whatever contaminants made their way in there that shouldn't be there, like your red Solo Cup. And then you have a container line that'll have intermixed aluminum cans, different types of plastic. And now you're finally in the position where you can sort everything out into the actual commodities. Some of the commodities at play here that actually you bale up and can sell are old corrugated cardboard. So all that cardboard, make a bale out of it. Mixed paper, which can be the magazines and the newspapers, all those spam mailings that for some reason we all still get. And then on the container side, aluminum beverage cans are one of the most valuable commodities because it's just really good pure aluminum. Water bottles made out of polyethylene terephthalate, natural high-density polyethylene, so milk jugs in the United States, colored high-density polyethylene, polypropylene, so all the different plastics. Now, this is where AMP starts to come in, because traditionally, on those lines, you would have people remove the contaminants to the paper, or you'd have people sort the different types of plastic apart from each other. And then time went on and we got smarter as a species and we started using near-infrared optical sorters. Near-infrared happens to be a wavelength of light that interacts with plastics really well. And so there are these machines called optical sorters that scan the different containers going on underneath it. And if it's this type of plastic, it'll fire a puff of air up and send that piece of plastic to a conveyor belt that's higher up. And if it's a different type of plastic, or maybe not plastic at all, it won't fire that puff of air and that thing goes down and through. Have several of those, and now, okay, you don't need a person necessarily to sort those things. You can automate the sorting task. And that's where recycling has been up until AMP, where I come from. What we're working on at AMP is using computer vision built with deep neural networks that are looking at just a normal red, green, blue camera looking at the conveyor belt, sending that imagery into a neural network that's been trained on a data set of millions and millions of objects. And its job is to localize where those objects are in the frames that it has and to predict what material it is and how confident it is that it is that material. And then we can instruct either a puff of air to do the same thing as what the near-infrared system is doing, or a different type of robot to maybe pick and place with the suction cup gripper or to vacuum away a piece of plastic film. Um, the big difference, though, because that sounds very similar to the near-infrared optical sorter I just mentioned, and in principle it really is, except that it's way, way cheaper to build. Near-infrared optical sensors are $50,000 per sensor, and so what you'll traditionally see in existing recycling facilities is they might have a couple of these optical sorters, or they'll have none, and they'll rely on human sorters to separate out all the material. And basically what that means is that they'll get what they can. And if they don't remove material, or if they don't remove enough of the contaminants, then the commodities they're making might not meet spec, or they'll just have less of that commodity pulled out, and the recovery of that facility will be lower. What we've been building up by building these AI-driven robots that automatically sort recycling at a lower cost is a different way to think about the facility. If you could, instead of having one or two of these really expensive automated optical sorters, what if you could have 20 of them and have that all fundable in the same cost of facility? Well, you might build the facility a little different. If you have 20 of these, then you don't have to necessarily maybe centralize how you're bringing the material all to this one location. Well, you have 20 locations where you can do this. It can suddenly be more modular and repeatable. And so the facilities that AMP builds simply require way less steel to build because we don't need as much conveyance to go from here and there. We don't need special built equipment that only does one thing and separates this type of material from that type of material. Because if you can see it, you can train a computer vision algorithm to identify it. It's not limited to just plastics. It can also work on paper. And so we're able to build these facilities that have, 20 or more of these optical sorters in there at the same price point, but it actually ends up being a lower price point because you don't need all of those conveyor belts and extra equipment. And so at the end of the day, you're left with a cheaper to build facility by a significant margin that also just extracts material more efficiently. It recovers the material at a higher rate because instead of a human who's picking at 35 picks a minute, you have 20 red, green, blue driven, AI driven optical sorters sorting 2,000 picks a minute. And so these are the facilities that AMP is building, partnering with existing folks in the waste industry and going out on new ventures of our own to show that, hey, this significantly makes the problem of sortation cheaper, which does things like open up new geographies to place recycling facilities.